Okay, we have our outputs. We don't have an activation function. Our familiar module TFNN contains a function called softmax cross entropy with logits. It basically applies a softmax activation to the output layer and calculates a cross entropy loss function simultaneously. This is a numerically stable function when we deal with very small numbers. Obtaining numbers that are too small jeopardizes our model if we don't deploy this function. I don't know if we need this adjustment for this example, but it is better to be on the safe side. Logits here have a meaning of unscaled probabilities. We expect our output layer to produce probabilities, but before applying softmax, they are unscaled. Softmax fits them into a probability distribution, where they sum up to 1, as we already know. Think about the logits as the outputs before being scaled by softmax. Alright, let's call this variable loss. So, loss is equal to TFNN softmax cross entropy with logits. We have two arguments, logits and labels. The logits are the outputs. Naturally, the labels are the targets as we are dealing with supervised learning. Alright, we have the loss, but we prefer using the mean loss as it gives a big performance boost, remember? So, let mean loss be equal to TF reduce mean of loss. TF reduce mean is basically the TensorFlow method to find the mean of a tensor. Alright, we have the model and the loss. I want to choose the optimization method. Let me copy the line we used in the intro. This part indicates the optimization method. Last time, it was the gradient descent, but we've gone a long way since then. We mathematically proved the adaptive moment estimation, or ADAM, coupled with batching is a much better alternative. Conveniently enough, the train module contains the ADAM optimizer. I'll just change the function from gradient descent optimizer to ADAM optimizer. I will also set the learning rate at 0.001. Again, that's a hyperparameter that worked well enough, but is not optimal. Play around with it to produce a better result. Alright, that's all we've seen so far. In the next lessons, we will show you how to implement batching, and most important, how to measure the accuracy of the model we've built. Stay tuned, and thanks for watching.